Welcome to our video on the congruency theorems. Before we get to the theorems and you have a front and back handout where you are going to take notes on those theorems, we need to understand some of the vocabulary that's used in those theorems. So on a separate sheet of paper, I would like you to write down the 5 words that you see here, and that is the vocabulary that we're then going to use in the theorems. The first vocabulary word is the included angle. So you'll be talking about two sides, and you'll know things about those sides, usually the lengths. You'll know things about those sides, and the included angle is the angle between those two sides. So an included angle is an angle between those two sides, the ones you're talking about. Of course, every angle is between two sides, but you'll be talking about two specific angles. Similarly, an included side is the side between the two angles that you're talking about. Of course, again, every side is between two angles in a figure like a triangle, but again, you'll only be talking about two specific angles, and the included side is the one between. As you may guess, a non-included side is a side that is not between the two angles. So I'm talking about these two angles here. My included side would be the one here, and my non-included side are either of these two. A hypotenuse. This is specifically for right triangles. Hypotenuse and leg, these are right triangle vocabulary. So in a right triangle, my hypotenuse is found across from the 90-degree angle. It is the longest side on my triangle. That's my hypotenuse. The legs are the sides that are adjacent to the 90-degree angle, and each is less than the hypotenuse. That is the vocabulary that we are going to need to know in order to be able to start looking at these theorems and to move to the guided handout that you guys have. Our first theorem is the side-side-side theorem. And that states that if 3 sides of one triangle are congruent to 3 sides of another triangle, then those two triangles are congruent. So if you look at our picture, we can see that if segment AB is congruent to segment XY, which we see that they are because they both have 3 tick marks. If that's true, and BC is congruent to YZ, which is true because those both have 2 tick marks, and CA is congruent to ZX, which we also know is true because they only have 1 tick mark, but they both have it, then our triangles ABC and XYZ are congruent. Next, we have the side-angle-side theorem, also known as SAS. And here it states that if 2 sides and the included angle of one triangle are congruent to 2 sides and the included angle of another triangle, then the 2 triangles are congruent. So again, the included angle is going to be that angle between those 2 sides that we're talking about. So here, if AC is congruent to XZ, and angle C and angle Z are congruent, and side CB and ZY are congruent, which we can see from the markings that those are all true, then triangle ABC is congruent to triangle XYZ. I'll let you guys take a look at this problem and pause here. Which pair of triangles is congruent by the side-angle-side theorem? Take a look. The key is this angle is the included angle. Jot down your answer and we'll go over in class. Angle-side-angle theorem, or the ASA theorem. This one states that if 2 angles and the included side of one triangle are congruent to the 2 angles and the included side of another triangle, so these are both included, then the 2 triangles are congruent. Here we can see that if A is congruent to X, which it is based on the markings, and AB is congruent to XY, the included side, which we can see that that's true based on they have 1 tick mark, and angle B and angle Y are congruent, they both have 2 tick marks. So if it's angle, side, angle, angle, side, angle, if those are congruent, then these 2 triangles are congruent. Again, being careful that this is the included side, the side between the 2 angles that you're talking about. AC or CB would be considered the non-included side. Again, pause here, come up with your answer. Which pair of triangles is congruent by the angle-side-angle theorem? And be prepared to explain. Again, focusing here on the included side. Bring your answers to class. The angle-angle-side theorem, also known as AAS. This theorem states that if two angles and the non-included side of one triangle are congruent to two angles and a non-included side of another triangle, then the two triangles are congruent. So here's where we're using a non-included side. So we see that if angle ACB is congruent to angle XZY, which we see that's true based on the markings, and angle CAB is congruent to angle ZXY, which we can see is true based on the markings, and AB is congruent to XY, a non-included side, then these triangles are congruent. If we didn't know that AB and XY were congruent, but we knew that CB was congruent to ZY, this theorem would still work. It would still be angle-angle side, because then in this case it would be these two sides that would be congruent, and it's still a non-included side. Take a look at these images and select the pair of triangles that is not congruent by the angle-angle side theorem. Bring your answer to class on Monday. Now let's take a look at the hypotenuse leg theorem. First, this theorem only works for right triangles. Only. You can see that my triangles in the picture are right triangles. If you don't see right triangles, you can't do this. So, if the hypotenuse and the corresponding leg of one right triangle are congruent to the hypotenuse and corresponding leg of another right triangle, then the two right triangles are congruent. So, first we have to know that these two triangles are right triangles. Then we need to know that AB is congruent to XZ, our two hypotenuses. And again, our hypotenuse is found across from the 90-degree angle. And if we know that AC is congruent to ZY, one of our legs, our corresponding legs. If we didn't know that, but instead we knew that CB was congruent to XY, that would still work, as long as we're talking about the corresponding legs. Then these two triangles are congruent. Take a look at this. Are the two triangles congruent according to the hypotenuse leg theorem? Explain. What do we know? And what do we need? What do we need for the hypotenuse leg theorem? Bring your answer to class. The reflexive property of congruence. A shared angle or side is congruent to itself. So this seems very intuitive, and it is. We can see here that BD is congruent to BD. This is an extremely useful property when we're trying to prove triangle congruence. In this example, we can say that angle G is congruent to angle G. Again, you'll see why this is so important as we work more with these theorems. What theorem and property can be used to prove the two triangles congruent? Again, let's make use of that property we just learned here. Now what do we know about triangle ABC and triangle ADC? Now let's take a look at the transitive property of congruence. If two segments or angles are congruent to a third segment or angle, then they are congruent to each other. If this angle is equal to this angle, and B is congruent to C, then A is congruent to C.